The Multiverse Theory, Exploring Infinite Realities to Fall Asleep to. Introduction to the Multiverse. Good evening, dear listener. As you settle into your comfortable space, allow your mind to drift gently into a state of relaxation. Imagine yourself floating effortlessly through a vast, serene cosmos, where stars shimmer softly against the velvet expanse of space. In this tranquil journey, we will explore the concept of the multiverse, a theory suggesting that our universe is but one of many, each with its own unique properties and laws. The term multiverse combines multiple and universe, implying a collection of distinct universes existing simultaneously. This concept challenges the traditional notion of a singular cosmos, proposing instead that our universe is part of a vast ensemble of universes. As we embark on this exploration, let your imagination wander through these infinite realms, each offering a unique perspective on existence. Historical context. The idea of multiple universes is not a recent development. Philosophers and scientists have pondered the existence of parallel worlds for centuries. In ancient Greece, the philosopher Democritus speculated about the existence of innumerable worlds, some similar to our own and others vastly different. These early musings laid the groundwork for modern multiverse theories, which have evolved through advancements in physics and cosmology. Scientific foundations. Several scientific theories have given rise to the concept of the multiverse. One such theory is cosmic inflation, which suggests that the universe underwent rapid expansion immediately after the Big Bang. This inflation could have led to the creation of multiple bubble universes, each with its own distinct properties. Another foundation lies in quantum mechanics, where the many worlds interpretation proposes that every possible outcome of a quantum event actually occurs, each in its own separate universe. Philosophical implications. The notion of a multiverse raises profound philosophical questions about the nature of reality and our place within it. If multiple universes exist, each with different versions of ourselves, what does that mean for concepts like identity and free will? These reflections encourage us to ponder the vastness of existence and our unique journey within it. As we conclude this introductory part, allow yourself to embrace the vastness and mystery of the multiverse. Whether these theories hold truth or remain as imaginative concepts, they open our minds to the infinite possibilities that lie beyond our current understanding. Let this contemplation guide you into a state of relaxation, preparing you for the deeper exploration that awaits in the following parts. Cosmic inflation and the birth of the multiverse. As we continue our tranquil journey through the concept of the multiverse, let's delve deeper into one of the foundational theories that propose its existence. Cosmic inflation. The theory of cosmic inflation. In the early 1980s, physicists introduced the concept of cosmic inflation to address several perplexing issues in cosmology. This theory posits that a fraction of a second after the Big Bang, the universe underwent an exponential expansion, growing from subatomic scales to macroscopic sizes almost instantaneously. This rapid inflationary period smoothed out any irregularities, leading to the large-scale uniformity we observe in the cosmos today. Eternal inflation and the multiverse. An intriguing aspect of the inflationary model is the concept of eternal inflation. According to this idea, while inflation ended in some regions, allowing them to evolve into observable universes like ours, it continued indefinitely in others. This ongoing process results in a vast, ever-growing multiverse, a cosmic foam where each bubble represents a distinct universe, with its own unique properties and physical laws. Implications of inflationary multiverse. The inflationary multiverse model suggests that our universe is just one of countless others, each potentially having different dimensions, fundamental constants, and even varying laws of physics. Some universes might harbor conditions suitable for life, while others could be entirely inhospitable. This perspective offers a profound shift in our understanding of existence, implying that the reality we experience is merely a small fraction of a much larger, complex multiverse. Observable evidence and challenges. While the theory of cosmic inflation elegantly explains several cosmological observations, such as the uniformity of the cosmic microwave background radiation, direct evidence for the existence of other universes remains elusive. Some researchers propose that collisions between our universe and others could leave detectable imprints in the cosmic microwave background. However, identifying such signatures amidst cosmic noise is a significant challenge, and as of now no conclusive evidence has been found. Philosophical considerations. The notion of an inflationary multiverse raises profound philosophical questions. If countless universes exist, each with its own version of reality, what does that mean for our understanding of existence? Are there other versions of ourselves living different lives in parallel universes? These contemplations invite us to reflect on the nature of reality and our place within the vast, possibly infinite multiverse. As we ponder these expansive ideas, allow your mind to drift through the cosmic tapestry, embracing the infinite possibilities that the multiverse presents. Let this contemplation guide you into a deeper state of relaxation, preparing you for the next leg of our journey into the realms of quantum mechanics and the many worlds interpretation. The many worlds interpretation of quantum mechanics. As we continue our serene exploration of the multiverse, let's delve into the realm of quantum mechanics, where the concept of the many worlds interpretation MWI offers a fascinating perspective on the nature of reality. Quantum mechanics and the measurement problem. Quantum mechanics, the fundamental framework for understanding the behavior of particles at the smallest scales, presents a peculiar challenge known as the measurement problem. In this domain, particles exist in a superposition of states, meaning they can be in multiple configurations simultaneously. However, upon measurement, they appear to choose a specific state. This apparent collapse of the wave function has puzzled scientists and led to various interpretations. Introduction to the Many Worlds interpretation, proposed by physicist Hugh Everett III in 1957. The Many Worlds interpretation offers a bold solution to the measurement problem. Instead of a single outcome materializing upon observation, MWI suggests that all possible outcomes occur, each in its own separate universe. In this framework, the universe continually branches into multiple, non-communicating realities, encompassing every conceivable event. Implications of the many worlds interpretation. The MWI implies that for every decision or random event, the universe splits into distinct branches. For instance, if you face a choice between two options, the MWI posits that both choices are realized, each in its own parallel universe. This leads to a vast, possibly infinite number of universes, each representing different outcomes of every event. Philosophical considerations. The many worlds interpretation challenges our conventional understanding of reality, identity, and free will. If every possible outcome exists in some universe, what does that mean for our sense of individuality and the significance of our choices? These questions invite deep reflection on the nature of existence and our place within the multiverse. Criticisms and alternatives. While the MWI provides an elegant solution to the measurement problem, it is not without criticism. Some argue that it leads to an overabundance of unobservable universes, making it difficult to test or falsify. Others propose alternative interpretations, such as the Copenhagen interpretation or objective collapse theories, each offering different resolutions to the peculiarities of quantum mechanics. As we ponder the many worlds interpretation, allow your mind to gently drift through the myriad possibilities it presents. Embrace the notion of a multiverse teeming with infinite realities, each a testament to the boundless potential of existence. Let this contemplation guide you into a deeper state of relaxation, preparing you for the next leg of our journey into the realms of higher dimensions and the brain multiverse. The brain multiverse and higher dimensions. As we continue our exploration of the multiverse, let's delve into the concept of the brain multiverse, a theory rooted in string theory and higher dimensional spaces. Understanding brains and higher dimensions. In string theory, the fundamental constituents of the universe are not point-like particles, but one-dimensional strings that vibrate at different frequencies. This framework requires additional spatial dimensions beyond the familiar three. Within this context, a brain, short for membrane, is a multidimensional object to which these strings can attach. Our universe, according to the brain multiverse theory, exists on a three-dimensional brain, floating within a higher dimensional space, often referred to as the bulk. Other brains, potentially with their own unique universes, may also exist within this bulk. The brain multiverse concept. The brain multiverse proposes that multiple brains coexist within the higher dimensional bulk, each hosting its own universe. These parallel universes might have different physical laws and constants, depending on the characteristics of their respective brains. Interactions between brains, such as collisions or proximity effects, could have significant cosmological implications. And the Big Bang. One intriguing aspect of the brain multiverse theory is its explanation for the origin of our universe. Some models suggests that the Big Bang was the result of a collision between two brains. This collision released immense energy, leading to the rapid expansion and heating of our universe. Such events might not be singular. Brain collisions could occur periodically, resulting in a cyclic model of cosmology, where universes are continually created and destroyed. Challenges and criticisms. While the brain multiverse offers a compelling framework, it faces several challenges. The higher dimensional bulk and other brains are, by definition, beyond our direct observational capabilities, making empirical verification difficult. Additionally, the complexity of string theory and the multitude of possible configurations, known as the landscape problem, make it challenging to derive specific testable predictions. Philosophical considerations. The brain multiverse concept invites profound philosophical reflection. If multiple universes exist on different brains, each with its own version of reality, what does that mean for our understanding of existence? Are there other versions of ourselves living different lives in parallel universes? These contemplations encourage us to ponder the nature of reality and our place within the vast, possibly infinite multiverse. As we conclude this part of our journey, allow your mind to drift through the vast expanse of higher dimensions, embracing the possibilities that the brain multiverse presents. Let this contemplation guide you into a deeper state of relaxation, preparing you for the next leg of our exploration into the holographic principle and its implications for the nature of reality. The holographic principle and the nature of reality. As we continue our exploration of the multiverse, we arrive at a concept that challenges our very perception of reality: the holographic principle. This intriguing idea suggests that our three-dimensional universe might be a projection of information encoded on a two-dimensional surface. Understanding the holographic principle. The holographic principle emerged from studies in string theory and quantum gravity. It posits that all the information contained within a volume of space can be described by data on its boundary. In simpler terms, our 3D universe could be akin to a hologram, where the depth we perceive is an illusion arising from information encoded on a two. Origins and development. The concept was first proposed by physicist Gerard Hooft and later expanded upon by Leonard Susskind. They suggested that just as a hologram encodes a three-dimensional image on a two-dimensional surface, the entire universe could be described by information on a cosmic boundary. Implications for black holes. One of the compelling motivations for the holographic principle comes from the study of black holes. According to traditional physics, the amount of information or entropy a black hole can contain is proportional to its volume. However, research indicates that a black hole's entropy is proportional to the area of its event horizon, the boundary beyond which nothing can escape. This finding aligns with the holographic principle, suggesting that all information within a black hole is encoded on its surface. The ADAS is CFT correspondence. A significant realization of the holographic principle is the anti-de Sitter conformal field theory,
ADAS is CFT correspondent. This theoretical framework proposes a relationship between a gravity theory in a higher dimensional ADAS space and a quantum field theory without gravity on its lower dimensional boundary. This correspondence has provided deep insights into quantum gravity and has been a pivotal development in theoretical physics. Philosophical considerations. The holographic principle invites profound philosophical reflections on the nature of if our perceived three-dimensional world is a projection of information from a two-dimensional boundary. It challenges our understanding of space, time, and existence itself. This perspective blurs the line between illusion and reality, prompting us to reconsider the fundamental nature of the cosmos. Challenges and ongoing research. While the holographic principle offers an elegant framework, it remains a theoretical concept. Testing its predictions in our universe is challenging due to the scales involved. However, ongoing research in quantum gravity and cosmology continues to explore its implications, seeking potential observable consequences that could validate or refute this paradigm. As we ponder the holographic nature of our universe, allow your mind to drift through the layers of reality, embracing the possibility that our existence might be a complex projection. Let this contemplation guide you into a deeper state of relaxation, preparing you for the next leg of our journey into the simulated multiverse and the nature of consciousness. The simulated multiverse and the nature of consciousness. As we continue our exploration of the multiverse, we arrive at a concept that intertwines the realms of advanced technology and profound philosophical inquiry. The simulated multiverse and its implications for the nature of consciousness. The simulation hypothesis. The simulation hypothesis proposes that our reality might be an artificial construct, akin to a sophisticated computer simulation. This idea suggests that an advanced civilization could create simulated universes, indistinguishable from the real one. If such simulations are possible, it raises the question, how can we be certain that our own universe is not a simulation? The simulated multiverse. Building upon the simulation hypothesis, the concept of a simulated multiverse suggests that multiple simulated realities could coexist, each with its own set of parameters and laws. In this framework, our universe could be one of many simulations, running concurrently, each exploring different scenarios and outcomes. This perspective aligns with certain interpretations of quantum mechanics, where every possible outcome of a quantum event is realized in its own separate universe. Implications for consciousness. The notion of a simulated multiverse invites profound questions about the nature of consciousness. If our reality is a simulation, is our consciousness also simulated? Or does consciousness exist independently of the simulated environment? Some theories propose that consciousness could be a fundamental aspect of reality, not confined to the physical substrate of our universe. In a simulated multiverse, consciousness might traverse different simulated realities, experiencing diverse forms of existence. Philosophical considerations. The idea that we might inhabit a simulated multiverse challenges our understanding of self, reality, and existence. It raises questions about the authenticity of our experiences and the nature of free will. If our choices are part of a pre-programmed simulation, what does that mean for our sense of agency? Conversely, if consciousness is independent and can move across simulations, it suggests a more profound, interconnected reality beyond the confines of any single simulated universe. Scientific exploration. While the simulation hypothesis and the concept of a simulated multiverse are largely theoretical, advancements in technology and physics continue to provide new avenues for exploration. Researchers are investigating the nature of reality, the fundamentals of consciousness, and the potential for creating simulated environments, all of which contribute to our understanding of these profound concepts. As we ponder the possibility of a simulated multiverse and its implications for consciousness, allow your mind to drift through these layers of reality, embracing the mysteries they present. Let this contemplation guide you into a deeper state of relaxation, preparing you for the next leg of our journey into the ultimate ensemble and the nature of mathematical existence. the ultimate ensemble and the mathematical universe hypothesis. As we continue our exploration of the multiverse, we arrive at a concept that intertwines mathematics and existence. The ultimate ensemble, also known as the mathematical universe hypothesis. This theory proposes that all mathematical structures exist physically, suggesting that our universe is just one of many within an all-encompassing mathematical multiverse. The mathematical universe hypothesis, proposed by cosmologist Max Tegmark, the MUH posits that our physical world is not only described by mathematics but is itself a mathematical structure. In this view, every mathematical entity exists in a physical sense, and the universe we inhabit is one such entity. This perspective implies that all possible mathematical structures correspond to their own distinct universes, collectively forming the ultimate ensemble. Implications of the ultimate ensemble. The ultimate ensemble suggests a vast multiverse, where every conceivable mathematical framework manifests as a physical reality. This encompasses universes with different physical laws, constants, and even dimension. In such a multiverse, the specific properties of our universe are not unique, but are simply one realization among an infinite array of possibilities. Philosophical considerations. The MUH challenges traditional notions of reality by proposing that existence is purely mathematical. This raises profound questions about the nature of physical laws, the role of mathematics in describing the universe, and the very essence of existence. If all mathematical structures exist physically, it implies a form of Platonism, where abstract mathematical forms have tangible reality. Criticisms and challenges. While the MUH offers an elegant and unifying perspective, it faces several criticisms. One major challenge is its lack of empirical testability. If all mathematical structures exist, it becomes difficult to derive specific falsifiable predictions about our own universe. Additionally, the hypothesis raises questions about the nature of consciousness and observation within such a vast multiverse. Conclusion. As we ponder the ultimate ensemble and the mathematical universe hypothesis, allow your mind to drift through the infinite mathematical landscapes that this concept presents. Embrace the notion that our universe may be one of countless mathematical structures, each with its own unique reality. Let this contemplation guide you into a deeper state of relaxation, preparing you for the next leg of our journey into the anthropic principle and the fine-tuning of the universe. The anthropic principle and the fine-tuning of the universe. As we continue our exploration of the multiverse, we encounter the concept of the anthropic principle and the intriguing notion of the fine-tuning of the universe. This idea suggests that the fundamental constants and laws of nature appear to be precisely calibrated to allow the existence of life as we know it. Understanding the fine-tuning argument. The fine-tuning argument observes that various physical constants, such as the gravitational constant, the strength of the electromagnetic force, and the masses of elementary particles, fall within a narrow range that permits the development of complex structures, stars, planets, and ultimately, even slight variations in these constants could render the universe lifeless, leading to the question of why they are set so precisely. The anthropic principle explained. The anthropic principle offers a framework for understanding this fine-tuning by asserting that the observed values of these constants are not random but are constrained by the necessity of supporting observers like us. In other words, the universe must have properties that allow life, otherwise we wouldn't be here to observe it. This principle comes in two primary forms. Weak anthropic principle. This version states that the conditions we observe in the universe are as they are because they allow for the existence of observers. It's a statement about the observational bias inherent in our measurement. Strong anthropic principle. This form suggests that the universe must have properties that inevitably lead to the development of life, implying a deeper connection between the cosmos and the emergence of observers. The multiverse as an explanation. One compelling explanation for the fine-tuning of the universe is the multiverse hypothesis. If there exists a vast ensemble of universes, each with different physical constants and laws, it's plausible that some of these universes would by chance have the right conditions for life, We find ourselves in one such universe, simply because it's one where observers can exist. This perspective aligns with the weak anthropic principle, as it highlights our observational position within a life-permitting universe, among a multitude of possibility, philosophical and theological implications. The fine-tuning of the universe, and the anthropic principle, have profound philosophical and theological implications. They raise questions about the nature of existence, the possibility of a purposeful design, and our place within the cosmos. Some interpret fine-tuning as evidence of a designer or a higher intelligence, while others view it as a natural consequence of the multiverse's vastness, where all possible conditions are realized somewhere. Critiques and counter-arguments. Critics of the fine-tuning argument and the anthropic principle point out that our understanding of physics is still incomplete. What appears as fine-tuning might eventually be explained by a more comprehensive theory that necessitates these constants values. Additionally, some argue that invoking the multiverse to explain fine-tuning is speculative, as other universes are by definition unobservable and beyond empirical verification. Conclusion. As we reflect on the anthropic principle and the fine-tuning of the universe, we are invited to ponder the delicate balance that allows our existence. Whether this balance is a result of a vast multiverse, an underlying necessity, or something else entirely, it underscores the profound mystery of why the universe is the way it is. Let this contemplation guide you into a deeper state of relaxation, preparing you for the next leg of our journey into the philosophical implications of the multiverse concept.
Philosophical implications of the multiverse concept. As we continue our exploration of the multiverse, we arrive at a juncture where science meets philosophy, prompting profound questions about the nature of reality, existence, and our place within the cosmos. The nature of reality and existence. The multiverse concept challenges traditional notions of a singular reality. If multiple universes exist, each with its own laws of physics and constants, it raises the question, what is the true nature of existence? Are these parallel universes as real as our own, or do they exist merely as theoretical constructs? This line of inquiry invites us to reconsider our understanding of reality and what it means to exist. Identity and the self. In a multiverse scenario, especially under the many worlds interpretation of quantum mechanics, every possible outcome of a decision occurs in some universe. This implies the existence of countless versions of ourselves, each leading a different life, based on varying choices and circumstances. Such a perspective challenges our sense of identity and individuality, prompting us to ask, what defines the self, if numerous counterparts exist across the multiverse? Free will and determinism. The idea of multiple universes also intersects with debates on free will and determinism. If every possible action we could take is realized in some universe, does that diminish the significance of our choices? Alternatively, does it suggest a deterministic framework where all outcomes are inevitable across the multiverse? These questions delve into the core of human agency and the meaning of our decisions. Epistemological challenges. The multiverse theory presents epistemological challenges concerning what we can know and how we can know it. If other universes are fundamentally unobservable, can their existence be considered a scientific hypothesis, or do they reside in the realm of metaphysics? This dilemma touches on the demarcation problem in the philosophy of science, questioning the boundaries between empirical science and speculative philosophy. Ethical and moral considerations. The existence of multiple universes could have ethical implications. For instance, if every possible action is actualized in some universe, does that affect our moral responsibility in this one? Moreover, how do we assign value to outcomes if all possibilities are realized somewhere in the multiverse? These considerations urge a re-evaluation of ethical frameworks in light of a potentially infinite array of realities. Theological reflections. The multiverse concept also intersects with theological discourse. Some may view the multiverse as a challenge to traditional notions of a singular creation, while others might see it as an expansion of the creative scope of a divine being. It raises questions about purpose, design, and the uniqueness of our universe in the broader tapestry of existence. Conclusion. As we reflect on the philosophical implications of the multiverse, we are invited to ponder deep questions about reality, identity, and meaning. This contemplation encourages a broader perspective on our existence and our place within the cosmos. Let these reflections guide you into a deeper state of relaxation, preparing you for the final leg of our journey, where we will synthesize our exploration and consider the future directions of multiverse research. Future directions in multiverse research. As we conclude our exploration of the multiverse, it is essential to consider the future directions that research in this field may take. The concept of multiple universes has evolved from philosophical speculation to a topic of scientific inquiry, and ongoing advancements continue to shape our understanding. Advancements in quantum computing. Recent developments in quantum computing have opened new avenues for exploring the multiverse. Google's quantum chip, Willow, achieved a computational feat by solving a complex problem in minutes, a task that would have taken traditional supercomputers an unfathomable amount of time. This breakthrough has sparked discussions about the potential of quantum computers to simulate aspects of the multiverse, providing insights into parallel realities and the fundamental nature of existence. Exploration of quantum gravity. The pursuit of a theory of quantum gravity, which seeks to unify general relativity and quantum mechanics, remains a significant focus in multiverse research. Advances in this area could offer new perspectives on the structure of the multiverse and address existing challenges. Researchers are developing models that integrate these fundamental forces, potentially revealing deeper insights into the fabric of reality. Technological innovations and observational techniques. Future research will likely benefit from technological innovations that enhance our ability to observe and analyze cosmic phenomena. Advanced telescopes and detectors may provide indirect evidence, supporting or refuting multiverse theories. As observational techniques become more sophisticated, scientists hope to detect subtle signals or patterns that could indicate the existence of parallel universes. Interdisciplinary collaboration. The complexity of multiverse research necessitates collaboration across various scientific disciplines. Physicists, cosmologists, mathematicians, and philosophers are increasingly working together to explore the implications of multiverse theories. This interdisciplinary approach fosters a more comprehensive understanding and encourages the development of innovative, philosophical and ethical considerations. As scientific exploration advances, philosophical and ethical considerations will play a crucial role in guiding research directions. The potential discovery of multiple universes challenges our understanding of reality, identity, and existence. Engaging with these profound questions ensures that the pursuit of knowledge remains grounded in thoughtful reflection. Conclusion. Our journey through the concept of the multiverse has taken us from theoretical foundations to the forefront of scientific research. As we stand on the cusp of new discoveries, the future of multiverse research holds the promise of expanding our understanding of the cosmos and our place within it. Let this contemplation guide you into a state of relaxation, embracing the infinite possibilities that the multiverse presents.